In this video, I will show you how to use Excel to work out this correlation coefficient R. First of all, let's highlight all the data. And for the table, we need to add borders, add all borders here, so that we can figure out the sum. First of all, I want to figure out the sum of all heights. Therefore, double-click this cell, put the equal sign, then do the sum. It's here. The data will be from B3, then to B52. Then put the enter. You will get the answer. For the sum of all weight, we put the equal sign and then the sum. SUM is here. It will be from C3 to C52. Then enter. For the average of height, we put the equal sign, then type average. It's here. The data still from B3 to B52. Enter. The average weight, we will do the same thing. Don't forget the equal sign, otherwise you won't get this function. From C3 to C52. Then enter. This time we got to use this formula for correlation coefficient to figure out this R. And also we can use this formula to figure out the linear regression line. Basically, we call this is a population standard deviation. Remember, if you want to use the graphing calculator to get population standard deviation, the notation for population standard deviation is sigma x, sigma y, and also the sigma xy. For your graphing calculator, this S sub x, S sub y, and S sub xy means sample standard deviation. When you want to figure out the population standard deviation for height, you will use for height minus the average height, then square, do the sum. Same thing to this standard deviation for weight. Then standard deviation for height times weight, you will do this two multiplication. Then sum divided by how many data you have. N is 50. Therefore, we need another 5 column. So let's highlight 5 column here. We will set up the column like this. We know the average height, that's 68.0524. So we will double click this cell, put the equal sign. You got to use this minus 68.0524. Then put the enter. Then click this cell, find this plus sign, and drop down to the 50 data. They will do this operation automatically for you. For the weight minus average weight, double click this cell, put the equal sign. Then the weight is here, minus. Average weight is 128.842. Then put the enter. Click this cell, then find this plus sign. Drop down to the 50 data. Then for here, it's height minus average height square. Double click, put the equal sign. You need to square this one. So use this symbol stand for square, then enter. Click this cell, find this plus. Drop down. Then we will do the same thing over here. Equal sign, don't forget. Then square. Enter. Drop down. For this one, that's height minus average height times weight minus average weight. So this one. But you have to put the equal sign, remember, here. Times is this symbol. Then click here, enter. Drop down. After this, we need to do the sum. So click here, put the equal sign, type sum. Double click here. Check from which row, what's the first data. It will be F3. You see, it's F3. Go to F52. So I will type F3, colon symbol, F52. Then enter. For this column G, equal sign, type sum again. It will be from G3, colon symbol, G52. Enter. Equal sign, sum. From H3, colon symbol, H52. So we add all the data from row H3 to H52. Enter. Now we will copy this table to the Word document. So we just need to highlight, right-click, copy. Now we will paste into this Word document, Control V, paste. For the height inches, I will put the Enter to organize this table. Then for here, height minus average height, we will use the math symbol. For Word document, you cannot use this symbol. We call this is a computer symbol. It's not math symbol. Therefore, we will go to Insert, Equation, then go here, find the bar, that's a H bar. So here you will see H minus H bar, that's mean height minus average height. I will change this one into square. So Insert, Equation. This is a square, so I will use that. I will copy this over here. We need to put the parentheses. Then square. That's how you do it. Use the same way you will change W minus W bar here, W minus W bar square, and H minus H bar times W minus W bar. Then we got to use the correlation coefficient formula to figure out this R. And we put into this formula population standard deviation for height equals the square root of this 163.018312 divided by 50. Then do the square root, you will get this. So we will get S sub W and S sub HW using the formula given. Using these two numbers, then you plug into this correlation coefficient formula, you will get a 0.594. For the equation of linear regression line, we got to use this formula. So why we can use that weight minus average of weight equals, we already figured out this correlation coefficient is 0.594 times population standard deviation. It's 12.759 for the weight. This is the population standard deviation for the height. Then times the height minus the average of height. I just plug in the numbers. So when you organize, you will get this function. This will be the linear regression equation for weight and height.